All right, what's up, guys? So today's new lesson is called writing polynomials given the roots. Okay, now when we're talking about roots, we're not talking about square roots. We're talking about solutions. So this word roots here can mean solutions or zeros. Okay, so those are all ways to describe the same thing. So when they say writing polynomials given the zeros or given the solutions, they're talking about the answers of the polynomial when solved, okay? So we've been solving polynomials by factoring, and we've set it equal to 0 and gotten the roots or the zeros or the solutions. But now we're going to do it the other direction. So we're going to be given the roots first, and then we're supposed to come up with the factors and then multiply out the factors and then come up with the polynomial, okay? So I'll show you guys how it works in this first example. It says here, write a polynomial of degree 3. That means our final polynomial will be x to the third power with roots 2 and then plus or minus square root of 2. Notice here, let's count the roots here. We have a 1, 2, 3. In other words, we have the positive 2, which counts as 1. We have the positive square root of 2, that's 2. And then the negative square root of 2, that's 3. So 3 total distinct roots. Okay, distinct meaning there are no repeats here. And it's quite simple to set this up, okay? What we're going to do is we're going to go ahead and write 3 factors here. Since we have 1, 2, 3 zeros, we're going to go ahead and put 1, 2, 3 factors. Okay, I'm going to set it equal to 0. The 2 would have come from a factor that looks like this, x minus 2, right? If I told you, oh, what's the solution for this one? Remember, this is linear. You just take the opposite of negative 2, and we would get a 2. Okay? And now for the positive square root of 2, okay, we're going to go ahead and put x minus square root of 2, and then x plus square root of 2. Okay? So remember, we're just doing the opposite of this number here. So the positive 2 came from x minus 2. The positive square root of 2 came from x minus square root of 2. And then the negative square root of 2 came from x plus square root of 2. Okay? And really, this is the most complicated part or most complicated step of the whole problem. The rest is just multiplication. So watch this. I'm going to go ahead and multiply these two here. These are called complex conjugates. Or actually, they're just called conjugates, okay? It's kind of like a difference of squares here that we're going to end up with here. So multiply here, x times x, and we get x squared. And then we're just going to multiply these two here. Now notice here, if I multiply a negative square root of 2 times a positive square root of 2, I get negative square root of 4, right? A negative times a positive is a negative, right? Okay? Now, what's the square root of 4? Oh, that's 2. Okay? And so this becomes negative 2. And so what I'm going to write here is x squared minus 2. Okay? Over here, I just bring down the x minus 2, and then I get equals 0 here. Okay? So notice I just simplified the conjugates here. X minus square root of 2 times x plus square root of 2 becomes x squared minus 2. Okay? And then let's go ahead and multiply these two together. X minus 2 times x squared minus 2. So we're going to do this on the side again. So I'm going to just do a box method, okay? So 2 by 2. So I'll put x minus 2 on top, and then x squared minus 2 on the side. So let's just multiply. X times x squared is x cubed. Look, that's the x cubed that we're supposed to have, degree 3. X squared times negative 2 is negative 2x squared. And then negative 2 times x is negative 2x. And then we have positive 4. Okay? Notice I have no like terms, so then that's all I got to write. I got to write here x cubed in standard form. Next we have minus 2x squared, then minus 2x, and then plus 4 equals 0. Okay? And that's it. Notice how we came up with this here. We basically have the polynomial that when solved would end up with these roots here. Okay, now we're not going to solve this here. We're just going to go ahead and leave it like that, and that's our answer. That's what the problem was asking for. It says write a polynomial, here it is, of degree 3, x to the third, there it is, with the roots 2 and then plus or minus square root of 2. Okay? Now, I need to point out that irrational answers, irrational means it has a square root in it, and imaginary answers, which we'll do in the next example here, always come in pairs, in opposite pairs. So notice here we have a positive and a minus, a positive and a negative square root of 2. Right here we have a positive and a negative 3i. Okay, these always come in pairs, one positive and one negative. So keep that in mind in case in the next example here we have one that only has a single irrational answer. This one here is just a positive radical 3. Well, we know that this comes with a pair, right? So what is the pair that comes with it? It'll be a negative square root of 3. But we'll get to that one in a little bit, okay? First, let's do this one here. Notice here the degree they tell us has to be 4. And so we should have 4 roots. So notice I have 1, 2, 3, 4. So those are my 4 roots. They're all accounted for. So I'm going to go ahead and put 4 factors. 1, 2, 3, 4, and then put equals 0 at the end, okay? Then I'm going to go ahead and begin with the positive 3i, right? It's going to be x minus 3i, and then x plus 3i, and then x minus 0, you can think of it as, which we'll simplify in a moment here. You'll see what happens to this, and then this will be x minus 1, okay? So whenever you have x minus 0, by the way, I could have written x plus 0 there as well. But any number, if you subtract 0 to it, the number doesn't change, right? Think about it. 5 minus 0 doesn't change. It's still 5. Or 10 minus 0 is still 10. So it doesn't change. And so for x minus 0, we're just going to leave x. Okay, so really this is going to be like this. Look, x times x minus 1. And I'll put the imaginaries at the end. X minus 3i and x plus 3i equals 0. Okay? So the x minus 0 just became x all by itself. Okay? So what I'm going to do is I'm going to multiply these two together. These are called complex conjugates. Conjugates is when you have, like what we have here, x minus 3i and x plus 3i. Okay? And so let's go ahead and multiply it like this, just the first and the last. So x times x is x squared. And then here, notice here I have negative 3i times positive 3i. So negative 3i times positive 3i. Well, a negative times a positive is going to be a negative 9. And then I times I is I squared. Now you should have learned this in integrated 2. That I squared is the same as negative 1. So negative 9 times negative 1 is going to be a positive 9. Okay? So that's what we're going to write right here. Positive 9. In other words, negative 3i times positive 3i is 9. And that's the work right here for that. So negative 9i squared, and then I squared is the same as negative 1. So negative 1 times negative 9 is positive 9. Okay? Now let's multiply these two together here. X times x minus 1. Well, that's going to be x squared, if I distribute here, x squared times x, right? X squared minus x. And so that's the polynomial. We still have to multiply these two out, so let's go ahead and do this. Let's go ahead and do the box method here. So this will be x squared minus x, and then x squared plus 9. And let's just multiply out all the boxes here. So x squared times x squared is x to the 4th. Notice we need a degree 4. That means we're going to have a 4th power. And then x squared times negative x is negative x cubed. And then x squared times 9 is 9x squared. And then 9 times negative x is negative 9x. And notice there are no like terms, so we just go ahead and write the polynomial in standard form here. X to the 4th minus x cubed plus 9x squared minus 9x equals 0. And that's our final answer. Okay? Again, it's degree 4, and the roots we already showed here, our work. We wrote out the factors that would have come from these roots, and then we multiply everything out, and that's what we get for the polynomial. Okay? Now, let's look at this one here. It says the degree is 5. So that means our final polynomial will have x to the 5th power, right? But let's count to see if we actually have 5. Notice we have 1 positive square root of 3. Then we have the plus or minus here. So that's 1, 2, 3 so far. And then 4. We need 5 roots. But we're missing one. Okay? And that's like what I was saying earlier, that these irrational ones come in pairs. So this one comes in a pair. Notice we have the plus and the minus there. This one, though, we only have the positive one. So that means we need to include here the one that they didn't write. But it's really a test to see if you really know that these come in pairs. So on the test, you'll see that on one of the problems like this with the roots, it's going to be missing one of them. And you have to know which one it's missing, okay? So they may have given me the negative one. You have to write the positive one, okay? In this case, they gave me the positive, so I wrote the negative one. Now let's count. 1, 2, 3, 4, 5. So that means I'm going to go ahead and write 5 factors. 1, 2, 3, 4, 5. So there's going to be a lot of multiplication here. So let me put this one here, the real one first. It's going to be x minus 4. Okay, then I'll do the irrationals here, the ones with the square root. So this will be x minus square root of 3. And then x plus square root of 3. And then this one's also irrational. So it's going to be x minus square root of 2, x plus square root of 2. Okay, so let's multiply the conjugates together. So it's these two here and these two there. Okay. So I'll do these here on the side here. It'll be basically x times x is x squared. And then notice here a negative times the positive is going to be a negative. But what happens when I multiply square root of 3 times square root of 3? Let's do that. Square root of 3 times square root of 3. Isn't that square root of 9? But what's the square root of 9? That's 3. So this will be x squared minus 3. So you see what happens here really? The number inside the radical comes out, okay? So same thing is going to happen here. So we have x times x is x squared. A negative times a positive is a negative. And what do you suppose we're going to put here? Square root of 2 times square root of 2 is 2, okay? For the same reason, this one is 3. And then bring this one down here, x minus 4, okay? So let's multiply these two out here. So let me do the box method here. It's going to be x squared minus 3 and x squared minus 2. So we have x to the 4th minus 3x squared. And then negative 2x squared. And then negative, a negative 2 times a negative 3 is a positive 6. Okay? Notice I do have like terms here. Negative 2x squared and negative 3x squared. So that's going to give me x to the 4th minus 5x to the 2nd power plus 6. Okay? And then bring down the x minus 4, and I'm not done yet. All these are equal to 0, by the way. I need to do a 2 by 3 here box. So let's go ahead and do that. 2 by 3. So on the side here, I'm going to put x minus 4. And over here, I'm going to put x to the 4th minus 5x squared plus 6. Okay? So x to the 4 times x is going to be x to the 5th. Notice we need a degree 5, and there it is. Okay? And negative 5x squared times x is going to be negative 5x cubed. And 6 times x is 6x. Negative 4 times x to the 4th is negative 4x to the 4th. Negative 4 times negative 5 is going to be positive 20x squared here. And then negative 4 times 6 is negative 24. Okay? Let me make sure I didn't make any mistakes here. So that's good. That's good. That's good too. This is good. That's good. And everything's right, okay? So let's look for any like terms. I see x to the fifth, fourth, third, second, first. No like terms at all. So it's going to be x to the fifth minus 4x to the fourth minus 5x cubed plus 20x squared plus 6x, I'm running out of room here, minus 24 equals 0. Okay, so sorry for the non-straight answer there, but it looks like this. Okay, it's a very long polynomial. X to the fifth minus 4x to the fourth minus 5x cubed plus 20x squared plus 6x minus 24 equals 0. Okay, last one. Notice here we have degree 4, and then we have the roots 1, 2, 3. Notice here, this one came in its pairs, so we're not missing anything here. So that means this one here is the one that's missing something. Now, notice here, we have 3. 1, 2, 3. So if it's a degree 4, that means this one repeats also. It repeats again. Okay? So those are my 4 solutions. And so I'm going to put 4 parentheses, right? Now let me do these here. X minus 0, x minus 0, x minus square root of 2, x plus square root of 2. But remember we did this earlier here? When it's just x minus 0, we can just write x and x, right? And so what's x times x? Well, that's x squared. So this will be x squared by itself. And then let's multiply these two here. X times x is x squared. And we did already above here, negative square root of 2 times positive square root of 2 is going to be minus 2 like that. Okay, we did that one up here. And then we're going to have to multiply this out. Now this is a 1 by 2, I could just distribute here. So x squared times x squared is x to the fourth. X squared times negative 2 is negative 2x squared equals 0. I'm done. Okay, there's nothing left to multiply. And so that's my polynomial with the roots plus or minus square root of 2 and then 2 zeros. Okay, there you have it.